Welcome, Algebra 2. Let's take a look at Chapter 7, Section 3, Simplifying Rational Expressions. One of our goals today, along with multiplying and dividing rational expressions and identifying horizontal asymptotes. 7.3. How about you practice what we did last class? You'll need to factor each of these. Hit pause, come back when you're ready. All right, welcome back, Algebra 2. So, if I'm factoring 2x minus 8, this is 2 times x, this is 2 times 4. They have a 2 in common. If I'm factoring x squared minus 16, that's a difference of 2 squares. X plus 4 times x minus 4. X squared plus 5x plus 4. This is a trinomial. Things that multiply to 4. 1 times 4, 2 times 2. Which ones add up to 5? Oh, 1 and 4 does. Things that multiply to 16, but add up to 8. Well, not 1 and 16, not 2 and 8, but 4 and 4. Now we look for twins, something on top that is the exact same factor on the bottom, like x minus 4 and x minus 4. We're allowed to cancel a twin. One top, one bottom. That should make a hole in our graph. Where does it make the hole? Well, add 4 to each side when x is 4. I don't know what y value it's equal to, but I can always plug that in. Now that I've canceled that, I can plug it in. We're going to cancel first, then we'll worry about where the hole is later. Are there any other twins? X plus 1? No. X plus 4? Yes, indeed. Here's an x plus 4, and I can cancel it with any one of these three. It doesn't matter. So, x plus 4. That should make a hole. Where? Minus 4 at negative 4. Asymptotes occur vertically where the denominator didn't cancel. So x plus 4 and x plus 4. We set that equal to 0. We just did that and said it was going to be a hole. So is it a hole or an asymptote? Can't be a hole asymptote. Can't be an asymptote hole. It's one or the other. Hole or asymptote. Hole, asymptote. Asymptote, hole. I don't know. What we could do, though, is if we simplify a little bit and then enter our equation into Desmos, we'll be able to see whether this here is a hole or an asymptote. So, let's see what's left after we're done canceling. We've got a 2. We've got x plus 1. And on the bottom, we've got x plus 4. And we've got another x plus 4, which I could write as x plus 4 squared. I'm going to put that equation in Desmos and try and take a look and see what my graph looks like. This is a missing point. This is either a missing point or an asymptote, but it can't be both. Well, here we go. Here's my graph. At 4, I have a missing point. Desmos will not show it to me. It's not that bright. The only way to get Desmos to show it to you would be to put in the original equation. But you'll see they have a y value. And where did they get it from? They took a 4 and they put it here and here into our canceled equation. Because we've removed the hole, we can now plug that in. So they went 2 times 4 plus 1 over 4 plus 4 squared. And they found out what the y value is to know where the hole goes. At negative 4, it's not a missing point. It looks like that graph starts dropping down into nothing land. It's like a sinkhole that opened up. We can see at negative 4, we have a vertical asymptote. It's a line that we never cross, never touch, never go through. We get infinitely close to it, but we never, ever, ever cross it or touch it. Forever. So the lesson here is that when you have something that looks like it might be a hole, but it could also be an asymptote, I guess the asymptote is stronger than the hole. This is not a hole, it's a vertical asymptote. A line that we can't cross, can't touch, never go through. Our hole, that's a missing point. It would look like this on my graph. A missing point. I have a graph coming along. I have a hole in it. I have the x. I plug that x in here and here and here to find out where the y value is for that missing point. Time for our new stuff. If we can multiply last class, we should be able to divide this class. Let's start off with just a fraction. And you might be thinking it's been a long time, if ever, that you divided fractions. Yes, you can use your ABC button. 2ABC3 divided by 1ABC2. But I'm not interested in these kinds of fractions. We're going to do this with x's. So it's more the process I'm interested in. We keep our first fraction. We flip our second fraction. And then we change it to multiplication. So we keep, we flip, and we change. KFC sounds yummy to me. If there's any factors that can cancel top and bottom, we would. But 2 doesn't go into 3, and 1 goes into 2, but it doesn't really help you because it still leaves you at 2. So multiplying straight across, 2 times 2 is 4, 3 times 1 is 3. That would be my new fraction. But how do we do it with this? Well, we keep the first fraction, and I'm going to leave a little room above it because I'm going to factor before I'm done. So keep, flip, and change. Now we try and factor, just like what we did last class, just like what the practice problem was that you started with today. So factoring x squared minus 25. This is a difference of squares. X plus 5, x minus 5. 4 minus x, that doesn't really factor. X minus 4, nothing in common, doesn't factor, there's no x squared. 2x plus 10, well that's 2 times x and that's 2 times 5. So this is 2 times x plus 5. And you might think that x minus 4 and 4 minus x are the same thing. But let me take a look and show you that they are different. Let's say that x is 1. Well, 1 minus 4 is negative 3. 4 minus 1 is positive 3. So they're very similar, but they differ by a negative sign. Whatever number you put in, you're going to get a difference of a negative sign, with the exception of 0. 4 minus 4 is 0. 4 minus 4 is 0. Any other number you put in, you're going to have the same number, but one will be positive, one will be negative. So for our purposes, what we want to be able to do is we want to be able to factor this. So instead of having x minus 4 and 4 minus x, what I can do is I can say this one here that's backwards, I could take out a negative, and now I have x minus 4, just like I have x minus 4. You don't have to do that with addition, because addition, it doesn't matter. But subtraction, order does matter. This gives me a negative x, there it is, and then negative 4, 2 negatives would make a positive. So I didn't really change it, but I did factor out a negative 1. Now we look for twins. Anything on top that is a twin on the bottom can cancel. Like x plus 5, x plus 5, that's going to make a hole in my graph. Where does it make a hole? Take away 5 from each side. At negative 5, we have a hole in our graph. We'll still need to figure out the y value in a minute. Anything else on top that has a twin on the bottom? X minus 5, no. X minus 4 with x minus 4. Remember, it's leaving you a negative 1 down here, negative sign. So we have another hole at x minus 4. Add 4 to each side. When x is 4, we have a hole. I'll need to plug it in to find the y value. So what's left in my equation? What's left up top? Well, we're left with x minus 5. What's left on the bottom? Well, we have a negative here and a 2 here. So to find where the holes are, we would take our negative 5, plug it in here. Negative 5 minus 5. Negative 10 divided by negative 2. On your calculator, this is exactly what you do. Negative 5 minus 5 divided by negative 2. Negative 10 divided by negative 2 would be 5. Then we'll take our 4, plug it in here. 4 minus 5 is negative 1 divided by negative 2. Negative 1 divided by negative 2 is 1/2 or 0.5. So that's where the holes are at in my graph. Are there any x factors in the denominator that didn't cancel? Anything with an x in the denominator that didn't cancel would make an asymptote. No? Then no vertical asymptotes. But we do have a graph that has a couple holes in it. My domain, x does not equal 4, does not equal negative 5. Let's take a look at what this graph looks like. I'm going to put the original in, I'm going to put the new one in, and we'll compare the two and see they should be the same graph, with the difference being one of them has a hole and one of them doesn't have a hole. There it is. And I can see there are no holes in this graph as I move along. One of my holes was supposed to be at 4, nothing there. One of them is supposed to be at negative 5, nothing there. So how do you see the hole in the graph? Well, you have to go back to your original equation. X squared minus 25 divided by 4 minus x times, no, it was divide. Divide, ooh, wow, that gets ugly, right? Maybe I'll do the keep, flip, change times the one that I flipped. X minus 4 divided by 2x plus 10. Hey, it's the same graph, right? Well, kinda. There's a hole here. Can you see how it says undefined? There's an open circle if I move on top of it. And I believe there's one here too. But until I actually click on it and know where it is, Desmos will leave me hanging. Desmos isn't smart enough to show me the hole without me clicking on it and finding it. My domain, x does not equal negative 5 or 4. So I could write that like such. Does not equal negative 5 or 4. Why? Because I have a hole there. There's missing points. I cannot plug those numbers into my original equations. I can only plug them into the simplified equation where I canceled out the holes. You and your group spend about 15 minutes dividing rational exponents. Keep, flip, change. Keep, flip, change. Come on back to your notes when you're ready. Welcome back. We've been talking a lot about asymptotes. There are two main types that we'll see right now. There are other types, but this is what we're focusing on. Horizontal asymptotes that go side to side, and vertical asymptotes that go up and down. We've said that vertical asymptotes are those lines you can't cross. And you can have an unlimited number of those. There is no limit. You could have a gazillion of them, doesn't matter. Or you could have none. Parabolas don't have any. A line doesn't have any. It's when the graphs get more complicated, where you're trying to divide by 0 that you see those. But those are the lines that we never, ever, 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 ever cross. How do we find them? We set the denominator equal to 0, and we find the things that did not cancel. Whatever didn't cancel is what we set equal to 0. That's where our vertical asymptotes are. Whereas a horizontal asymptote, there's a maximum of 2. You might have 1, you might have 2, you might not have any at all. Parabolas don't have any, lines don't have any. A graph will usually not cross a horizontal asymptote. Well, usually means sometimes it will, sometimes it won't. Versus never, ever, 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 ever crossing a vertical asymptote. How do we find these? Well, write this down. Bobo Botan eats DC. We'll talk about what that means here in a second after we take a quick look at Mr. Bugs Bunny showing us what does it mean to maybe cross a horizontal asymptote, maybe not.
Start walking, you doggone long-eared galoot.
Just a minute, partner. You can't talk to me like that. Them's fighting words.
Them's fighting words.
I dare you to step over this line.
Okay, I'm a-steppin'.
I dare you to step over this one. This one. This one. That one. That one. This one. You know, sometimes me conscience kind of bothers me. But not this time.
Bugs should have used a vertical asymptote instead of a horizontal. I mean, you can never cross over a vertical, but you can cross over a horizontal sometimes. Holy shift, look at the asymptote on that mother function. Yeah, see, we've got a rational function here. It's been shifted to the right. That's your x minus 1. And we've got that vertical asymptote right there. I don't know what you guys are laughing about. What's an opinion without 3.14? Well, if you take out the pi, take out the p and the I, you just get an onion. So what is this Bobo Botan eats DC thing about to help us find horizontal asymptotes? Well, here's DC. I painted that. Is it pretty good? Yeah, I found that on Google. I admit it. I've been working with Mr. Beltrando. He's been helping me with my artwork. So here's Bobo. He said I'm getting really good. And Bobo is a hungry boy. Bobo is going to eat DC. And let me give him a lot of hair. Okay, there we go. Bobo Botan eats DC. What does it mean? Well, it means if we have exponents that are bigger on the bottom, bigger on bottom, B-O-B-O, then my answer is y equals 0. I compare the exponents in my fraction. I look and see, where's the exponent bigger? If the exponent's bigger on the bottom, then I have y equals 0 as a horizontal asymptote. Here would be an example. Y equals x over x squared plus 1. This exponent's 1, this one's 2. Where's it bigger? Bigger on the bottom. I know that y equals 0 is a horizontal asymptote that I'm probably not crossing. B-O-T-N. Bobo Botan. Bigger on top. B-O-T. Then the answer is none. There is no horizontal asymptote. Remember, we could have 0, 1, or 2. What would be an example? y equals x cubed over x minus 2. Exponents 1, exponents 3, bigger on top. There is no horizontal asymptote. So if our exponent isn't bigger on the top or bigger on the bottom, what must happen? Then the exponents are the same. Exponents are the same. And the way we find it is we divide our coefficients. Coefficients are the numbers in front. For example, y equals 8x plus 3 over 4x minus 1. Exponents are the same. This exponent's 1, this exponent's 1. So what do? We take 8 divided by 4. 8 divided by 4, y equals 2 would be my horizontal asymptote. We'll do a little matching here. Try and take the equation and put it in the right spot. Is it Bobo, is it Botan, or is it Eats DC? So, Bobo, bigger on bottom. Find one that has an exponent that's bigger on the bottom. Here, exponents 1, exponents 2. My answer, y equals 0. Bigger on top. Well, this exponent's 3, this one's 2. Bigger on top, there is no horizontal asymptote. Exponents are the same. Well, 3 and 3, 1 and 1, 1 and 1. So all of these here, all of these here, our exponents are the same. How do we find our horizontal asymptotes when the exponents are the same? We divide our coefficients. So let's try that. 1 and 1 is my exponent, so I take y equals 2 divided by 8, which is 0.25 or 1/4. Exponents 1, exponents 1. I take 1 divided by 1. My horizontal asymptote is 1. Exponents 3, exponents 3. Exponents are the same. I take my coefficients, -1 divided by 1. My horizontal asymptote is -1. So you divide your coefficients if your exponents are the same. You guys are going to spend about 15 minutes doing asymptotes of rational functions and Desmos. If you're working with a partner, please put both your names in. And then there is a Kahoot for you to do. If you don't finish it or don't start it, consider it homework. You do have a quiz practice, quiz next class, study. Good luck. See you next time.